Thank you, Jen.
You're welcome.
Hello, good afternoon. Thank you. Thank you for stay late with us. Yeah, I'm Kenny here from Google. I'm a custom engineer, data specialist, coming from Maryland. Here's my partner, Tobin.
Hi, everyone. I'm Tobin McGilligan. I'm a project manager at Carto. I came from the DC area as well, and speaking up here with Kenny, we actually discovered we flew in on the same flight on Monday, believe it or not.
Thank you. And we're going to talk about data. Today is Chris and many other speakers set up the tune very well for us. And you knew data is very important to you. And we are probably on this session, we're more focused on operational area about the data. First of all, I would like to show hands. How many of you do managing data or writing the code? All right, some of them, okay? Then I assume rest of you just manage the money. Is that right? You set a project up, then you run your projects. All right, and I can skip this slide. And basically, you all know data has become the new oil, right? And for the person, it's property, and for business, it's capital, and for government, I assume many of you we do work with or related to government. That's what? Power. Okay, we want the data. We generate a lot of data, and we use a lot of data as well. And on this slide, I want to show is, look around, you see, and we, in terms of data, we have internal, external customers, we access data, and we also very much, care about data governance, data securities, and we, on the right side, this right side yours, and we also generate a lot of data. We like to see, and many of those data are generated in government, especially, usually is driven by the programs, right? So if you run your programs, you run your projects, you get funded, and you are the owner, and you want to remain owner of your data. So usually I call that data ownership is distributed. But when it comes to consumer your data, we would like to break the silos. We want to share the data. And today, I'm going to talk more about in Google Data Platform, how we do that. What's the advantage? And we're very proud in Google Cloud Platform, we are leaders in smart analytics. And I'm going to show and demo some advantages, features, and you can see why we say so. And again, besides that talking, I would like to more interactive. If you have questions, please ask questions. And if you have some projects in your mind, come on, let us know, please. And from the government, here in Hawaii, we have a Medicaid, Medicare. We know that's one big program, right? Every state, that's one big program. And we also have some other departments. We all generate a lot of data, structured, unstructured. And all those data is very important for us to execute our mission, help our citizens and our visitors. On this slide, and I'm just glad Chris and Daniel or someone else didn't show this slide, so it didn't steal my thunder here. This is the Google Data Platform. And on the top, we have a persona to see who is going to be using my data. From the left, you can see we have data engineers, who the person prepare data, transfer data, load data, and make data available, accessible. Then we have machine learning engineers. Daniel mentioned it in last session. They run generative models, evaluate models, apply models, and help us to make decisions. Left, then one more is like a data scientist, okay? They do a lot of those kind of explore the data, do the data feature engineering, and also evaluate the models. In the middle, we have developers. We build applications, present the data, dashboard, visualize data, and also combine our data with maps, like Cardo to do. They're the expert in this area. And we're from Google Cloud, we're very fortunate as Cardo help us to visualize and build application, help our customers enrich their experience. Moved right further, then we see the data analyst. A lot of those is for like a traditionally, we call business intelligence, building reports, because in the business, especially government, we have a lot of this report. We got to report to our citizens, we got to report to the federal government, or report to our partners, right? We do a lot of those kind of work, and then we have a business users. Many of the, I just take one example, let's say policymakers. Many of those are policymakers, and we are doing a lot of data-informed business. We want to see or learn, if I set this policy up, what's the effect? Further, there will be consumers in this island, will be most likely will be our residents and our visitors. And the line below, and is the blue box, that's a full life cycle of our data. Typically, the collect data, ingesting data, or process data, store data, analyze, then activate data, and empower you or feed the data back to your application. And then the line below, you see each of those boxes. These are products, services provided on the Google Cloud. We assist you. For instance, in collect section, we have a pops up, which is a stream or messaging queue, help you load the data in real time, and the data stream help you manage, migrate the data, load into Google Cloud platform real time. Then we also have data migration services. Mostly it's doing a batch time, migrate data in a batch. And we have data transfer services. Then down the bottom, you see many, many logos. That's it. We have a pre-built connectors, help you pull data from the different platforms with a click of a button, then start feeding data into BigQuery, so you can do analytics on it. In the middle, that's where we can do data transformation, data extraction, data loading, and then line below, the column below, that's where we store data. We can store data in relational database. We listed some of them. We also can store in documentation database. We can store in object storage, you name it, many of them. And the line below, the column next is our storage, which is the center of our data platform. It's BigQuery. Within BigQuery, and one piece we have is called BigQuery ML, BigQuery Machine Learning. So you can write or generate a model using SQL statement. And you do not need move the data out the BigQuery database. You can do the machine learning in place. We support a dozen of data modeling types, and help you pick up and apply ML technology quickly, easily. Next one, then we talk about the Vertex AI. Daniel mentioned them many times, and the APIs. I'm not going to talk too much about that. And last columns, we talk about how I use the data and how I build applications. I mentioned the Cardo. I'm going to do some demo of Lookers. And from the whole process, on the left column and the right column, you notice them as similar. That's where the data source is. That data source could be your internal application, could be from your SaaS application like a Salesforce, ServiceNow, whatever the system you're using. Or could be some networking devices. We heard about Mandiant talk about securities, right? A lot of those security, how do we know what happened? All these events are generated from our network devices. Those devices, we could ingest all those data, and many of our customers does that as well, into BigQuery, then we can do analysis. Once we're done with analysis, and we have a tool and a way to send the data back to your application, which is rightmost. So that forms a full circle. So we the data platform we provide lets you get the data from where the source generated, do the processing, do the machine learning, then send the data back to your applications. So it's actionable, and you can truly see not only insight, but see the values from your data. Any questions? All right. When you talk about BigQuery, that's our data analytics engine. Also, I want you to know on Google Cloud, we have a product called Cloud SQL. Under the umbrella of Cloud SQL, we have a MySQL database, Postgres database, in a new generation we call AlloDB, and also have a Microsoft SQL Server. On Google Cloud Platform, we also support Oracle database. We support a Spanner database. That's another huge, large, distributed relational database at planet scales, literally planet scales. Means you have one database, you have a multiple agent across the world. Okay, have any of you used the database before? Wonderful, thank you. And you're probably familiar, I just take this shot from Oracle database architecture. And I worked at Oracle about 19 years. And I worked in the Oracle Global Solution Lab. That's the first generation Oracle Exadata. And I'm the one took those data machine, put it in the lab. We sold the first batch of all those servers. And one thing I want to show you in comparison with Google technology is, in old days, any database server coming, you install on one server, right? Or one rack, which is the largest that you can have. You cannot separate compute or storage on those kind of server. Mostly, when you set up your database server, you get your money, you buy the server, you use it for your own programs. If other one wants you using your data, what do? Do you let them to use that server? Most of the time you say, no, that's my money. I won't do that. So naturally, the silo, I don't blame you to run the programs, but see, the technology not enable you to break that silo. Because physically, your data has to be stay on that server, right? Now, here's the BigQuery architecture in comparison. What do we have? The BigQuery itself is a services just like Google search. When using Google search, do you care where the server is? You don't. Do you know where the server is? That's not my business, right? Same way. In Google, BigQuery is a serverless platform. The BigQuery server actually running in our Google Cloud region. In the region, we have a multiple data center. At the least, the BigQuery will run in 2 data centers at the same time. Beneath, we have, on the right side, we have a processor engine. Large typical setting is we have 20,000 servers running CPU memory to support BigQuery. On the left side, there's storage. Typically, we have 200,000 servers for storage. We keep 5 copies, physical copy of your data for redundancy, and we also enable service for your DR, disaster recovery. I remember the meeting, John was talking about DR. Do you have a DR plans? We build in DR for you. And for the regional, and 2 data centers, and we build a DR in place for you, and it's free of charge. But if you want to see multiple regions with a small amount of money, we can enable you to set up you determine where your DR site is. You know, for instance, you have one as an LA, and you can another one in the central, the mainland, like let's say For instance, you put it in Vegas, that's another your DR site, or far, you put it east, it's up to you. Then in the middle, we have a petabit network to connect all the compute engine and the storage engine. And this architecture enable Google, we can send our user the bill to say buy storage or buy compute, or you run the query. So you can split the bill. And also another advantage is you never worry about installing software or upgrade software. We're taking care of that for you. Behind the surface or browser, when you access BigQuery, we actually maintain three data centers, because one always be the standby. You do the maintenance. When you do the maintenance, we have only 2 active, so 1 standby. So that's how many server or architecture advantage we have. Think about any other database you're using. They're asking you to create clusters. They're asking you the size of server. For the BigQuery, simply, if you want to use the BigQuery, come to Google Cloud, go into the projects, just click to enable. If you enable BigQuery services, you got it. The reason we ask you to enable, because that was related to the billings, right? We don't want us to say, hey, you're using some service without knowledge. We want you to say, hey, click on it. Now we can bill you. We don't want to cheat you, right? That's not a Google policy. All right. On this slide, on the leftmost, and we also provide in BigQuery, you can load the data, ingest data real time. We call it streaming. Or you can load data in the batch mode, which is free. We will not cost you any money, not like other service providers. You have to set up an additional cluster to load the data. On the right side of yours, and we say there's 4 features. BigQuery SQL, and that's the language you're using to access data, manipulate data, create machine learning models, and that's a standard-based and ISO 2011 compliant. And to access BigQuery, you can use REST APIs. You can use web user interface browsers. I'm going to show you later for the demo. And also, you can use a command line interface. Down below, you can use 7 different client library, like a Go language, or C# or Node.js. So you can embed all those code in those applications, in your applications, to access BigQuery. Any question? All right, and here's some advantages if you come in with BigQuery. Serverless. Another one, we mentioned AI first. So because we built in this BigQuery machine ML, so you don't have to move data. You can do your machine learning in place. And also in BigQuery, we provide easy and multiple paths for you to extract the data, load the data, transform the data into BigQuery. You know what? Since we're talking here, I want to show some examples here. You can see this is a typical BigQuery user interfaces, and I'm going to start from upper left. You show you how to add the data, then come down. You can see there's a search button. We're a search company, right? So if you have so many objects, so many files, you want to see where they are, you can search. And the line below, you see this is kind of tree structure list. This is followed by the list of projects you have. Within the project, BigQuery service, you can create multiple data sets. Each data set is kind of like a database. Yeah, in Oracle, you create a database. So does in the SQL Server, you create a database. Within that data set or database, you can create views, you can create your queries, you can create your machine learning models, and you name it. And then if you click on each of your tables or data sets, you can open, then in the middle, there's a major real estate you have. Then we call the workspace. And in this workspace, you can put in the SQL statement. Chris Hine earlier on, and he showed multiple examples, slides. And I'm going to show the live demos later. And then you can put a query there. And you also can change some, you can set up the schedule to run my query periodically. And you can save your query, you can share your queries. And once you put your query statement there, and you notice in the upper right corner, you see the cost. So once you put your query statement there, now Will tells you in BigQuery, this query, how many megabytes, gigabytes, terabytes, or petabytes this query gonna be run through. Because many of you probably, if you go using BigQuery as an on-demand model, you probably say, my bill is generated based on how many bytes processed. So you want to know before you run it, right? Oops, fall asleep. And oh, I think a light bulb. All right, come back, good. All right, we'll have a DR built in. We just failed over. And when you run a query, and each query is a job, then you can see we have a job information, then we have a result, and like a list of format here. Then we have a result in JSON format. Then we have an execution detail. That's where the execution plan. If you are the DBA or SQL developers, many cases when I run my database, especially large queries, when I want to see, hey, which part cost that much? Why? Can I tune, improve the performance? Down the move to the right. And we also provide in the same, this Google BigQuery UI, you can save the result, or you can explore. You can explore result, you send your result to either save the file, or you can send to the Google Sheet. And you can do, I believe Chris was mentioned, pivot tables in the Google Sheet. Or you can also send it to Looker, and you generate a dashboard. And move down in this BigQuery user interface. We also keep the log of all your personal or project job history. So you knew who run what query when. If your job failed, also capture here. So you have an audit trail. So this is very helpful, not only for security, but also for troubleshootings, right? Okay, any questions? Yes, please. Very good question. All the databases, we do cache data, yes. One thing I did not mention is like a BI engine that's coming with BigQuery. That's our cache engine, so we can keep most frequent run data in the memory. For the same user, yes.
And then what is the cost like on cache queries?
0. Nice. For 24 hours, up to 24 hours. So if I run a query, thank you for your question. In the database world, we all know this, right? If I have a dashboard and I have new data come out, then I want to run that query and put on the dashboard. And then people coming to visit it, hit. But within 24 hours, that data is cached, and the query cost is 0. Yes, second question.
This is just me being super cheap.
No.
24-hour refresh. But what if I say just refresh every 22 hours, and it's cached and it just continues on?
The cache, the condition is, not continue on. When we run the first query, we know the timestamps. Then we're going to keep, based on that timestamp, we're going to keep up to 24 hours. Second is we're going to see how many queries. If I run 100 queries, we may have enough memory. I can cache all 100 queries. But if you run 2,000 queries, we run out of cache memories. Then first in and first out. So all one is going to be not cached. Excellent question. Thank you. I don't have a candy here. I should award you.
I think I've had enough candy, but BI connection where it's cached. Like I think there's some other platforms that are doing that, like that semantic layer.
Yes,
So do you guys have the Tableau connector?
we do. Yeah, we connect to pretty much every BI products, Tableau, Power BI, Looker, Oracle EBIE, what is another one? Cognos, yes, tons of them, yes. Yeah, and thank you for that question. And another piece I want to bring out is if you migrated your data warehouse from another platform to BigQuery, within BigQuery, we have to help you translate a SQL statement. All right, now here is a BigQuery. This is the live demos, and as I said, I click the up, right, leftmost, and I say add data. In this web console, you can see I can bring up this dialog box. I can load the file, ingest the data from my local drive or Google storage, or I can get data from like external data sources. Yeah, for instance, and like a S3 box or Azure Object Storage. I can also get data, let's say Amazon S3, Azure, or I can get data from public data sets. Remember the Chris Hine mentioned earlier, you can have a public data set and ready for you to use. I click on this one. In a public data set, there's many, and Google has this called a data residency program. So Google say we work with some customers, public or private. So we're going to pay the money for the storage. Okay. So if you want to using, for instance, like CMS data or some other agency or vendor's data, and you can use it under your fingertip. The important piece of this is it's no issue to get history data. The most valuable is many of those data, they are updated on daily basis. So the real time or near real time, that's the true value of this public data set. In addition of this public data set, we open up this facility for you, for your enterprise. So what do I mean by that? Is that we can let you create your private information exchange. So you can create your data sharing among the agencies, among the different departments, so you can share data. You retain ownership. So I own the data. I do data cleanup. I do data refresh, and I grant you access. And anyone interested, you come into the add this data, and you can see, I believe that Chris mentioned the CMS, right? So this is a live demo. This is a live system. Now you can see all those CMS data available under your fingertip. You can access, grab it, and you only pay for query you run. And storage, Google will pick up the dam. Any questions? Okay. So this is a SQL workspace. This is data transfer services I mentioned earlier. So one thing we run into in a lot of analytics or data warehouse or lake house is, how do I get my data? This tool, we have a built-in functionality for you to load the data. So you can easily create a data transfer here. You just specify what your data source is. You can get your data source, you can see from Amazon, S3, Azure, any of those big players, Google Ads, many our Google customers using Google Ads. And if you want to do deep analysis, you just on the Google Ads site as admin, you say enable, push data over to BigQuery, then you come over here, you click on it, yes.
What's your transfer speed like for Google Analytics?
When you enable transfer Google Analytics this data, and I remember was like we are gonna moving data like twice. This is batch, okay, twice a day. Some is we get by hour, depends. So we do gradually, every hour or every day, then we start sending data over. I gotta go back to check the service level agreement. Sometimes we guarantee data will be moved over in 24 hours. Sometimes it's 12 hours. It depends. And also, if you are workspace users, so people who want their CCAI, they missed this presentation here. Any CCAI data can be transferred over as well. Any other questions? Now you can see Google Merchants and a third party, Teradata, Oracle, Salesforce, and the search ads, YouTube. So a lot of those data, you can create a session and move data over. I talked about the Analytics Hub earlier. That's where we say you can create your information exchange. This is an example. This is where we create information sharing within our private projects. Dataform, that's another tool we built in BigQuery. What it would do is help you transform data. If your data accessible in BigQuery already, then you can use in Dataform and then merge data, change data format, clean up the data. Of course, we also have a partner centers and migration. This is I talked about earlier. So you can do the assessment or you can do the SQL translation because many of our customers, and I name just the two big ones like a Home Depot and Walmart. They have a huge Teradata database. A lot of those retailers, right? They usually run a lot of their data from other platforms. And in Google BigQuery, we built this tool. So if you run data warehouse on other different platforms, Netezza, Oracle, Postgres, or AWS, and we in BigQuery today, you can take that SQL statement, we do translation for you. I would not say 100% translate successful, but 80%, more than 80%, that's what I see internally. Why we cannot do 100%? That's because different database platforms, and they have their own out-of-line standard compliant features. That's, yep. Any questions? Time-wise, good? Okay. And BI engine, that was I talked about a cache engine. And also do the policy. In BigQuery on data securities, we let you secure at a project level. We let you secure at a data set level, which is database level. We let you secure data at a table level, view level, column level, row level. Yes?
For security aspect, does it tie into like Azure Active Directory or Azure?
You can enable Active Directory, yes. Okay. Yes. And you can enable Active Directory with Google IAM. We're using identities. You maintain it in Active Directory. Yes, we can do row level security, column level securities. Yes, row level security, column level security, if you're not familiar with, which means it depends on which user group you fall in. So you run same query. You're coming from different group. I let you see all the columns, or I limited you say, hey, there's a salary columns, there are social security columns. If you're not HR department, you cannot see it. And even you are in HR department, then we can say, hey, if you're not in a HR like a manager or director level, we will not let you see our managing chain people's salaries. So that's role level. Okay, row level security, column level securities. Thank you. Appreciate it. Okay. All right. Now let's go. I mentioned about BigQuery. I mentioned about data sets. Now you can see if I can create tables. So I can go upload the data. I can pick the file. And as you can see, I believe this is CSV files. I just called, yeah, DOH. So if I have a file or data in Excel, then I can save them as a CSV. I can load it. Then BigQuery will automatically create a table for me. Once I get the data, I can look at, this is my data schema. Then I can look at the details. See, when the data has been loaded, I can preview the data. I also can see, do the table explorer, and I can see, hey, I want to select some columns. I want to see, hey, say, I go by some genders, state, and social security number. Then I can save. Then you can see, then in BigQuery, I can explore to say, hey, in Massachusetts, male, how many in our records? We have 5 records with those social security numbers. And I can check this off. I can see in my table how many females I have in these tables. Okay, so this is the tool in place, help you learn your data. It's very helpful for data scientists or business analyst. And this table is just created. I don't have a lineage, but if I do the transformation using data form, in the BigQuery, I can show you data transformation. I can show the data lineage. You can also run the query, and let's see, if I go to schema, do something quick. I can go, you see the SQL statement, I can just click social security numbers, first name, last name, first name, phone numbers. You can see the 425 bytes that can be processed. I run it. Then you see the result come back. I can see explore my data. I send the data to Looker. I send the data to Colab to do machine learnings. I also can send the data to Explorer. If I send the data to Colab, and I can go to, and for instance, and this is the Looker demo I had earlier. And this data is on the Looker, and Looker provides like a visual dashboard. And I can see, this is like a claim. You think about the government, we do a lot of those claims, right? We build those applications. We want to see, investigate the fraud. Passwords time out. I got to log back in. In the Looker, and I can see my data. I can drill in. I can write comments. Come on. Besides the Looker, I do the data presentations. For instance, if I'm interested to like Allison House, this is the top case we have. I can add notes. I can view the beneficiaries. Daniel mentioned previously, document AI, a lot of safe travel information. You can see in BigQuery, we store those information. We can work with Lakehouse, so some driver license or your documentations we present, we display it in your application. then here you can see the driver licenses. You can add nodes, or you can go to, let's say, HR eligibility document, so I can see, check on this person's 1099s. All right. Okay. 3 more minutes, right? Okay. Thank you. So now you see what you can do with Lookers. And the last thing I would like to show is we have a platform called Data Fusion. In Cloud Data Fusion, what this does is the data ingestion I showed you before is loading data, transform data, but how do I do extract? So the Cloud Data Fusion let me to extract the data from third-party databases. The Cloud Data Fusion is another product in parallel of BigQuery. We can load the data from additional, like I say, Spanner databases. I can get the data from Spanner database. I can do the transformation, and I can do the data masking. I can do the data merge, and I can build a pipeline. I can have a batch load. I can have a change data capture, load the data real time, and then build a on top of these applications. And once you have this application, you have this data, and you, of course, you say, hey, if I have a geo data in my BigQuery tables. If you do, now it's perfect time. We talk about the maps. There you go. Oh.
Thank you, Kenny. And hello again, everyone. I'm grateful to be here today to speak a little bit about the, oh no, we can leave it plugged in there, sorry. Yeah. Oh. Oh yeah, I'll just start with this slide. Okay. It's great to be here today to speak a little bit about the geo-visualization and analysis capabilities that we at Carto have actually built on top of Google Cloud. Now, Carto is just one part of the solution architecture that you see depicted on the slide. Kenny, Chris, Daniel, earlier today have done a great job sharing a lot of information about a lot of the layers in this diagram. What I'm going to spend 10 to 12 minutes talking about now is the topmost layer, which is the visualization and analytics solutions that really activate this data, empower users, turn that data into compelling and actionable insight. The first thing to know is that Carto is a cloud-native geospatial platform. It was born in the cloud, it was raised in the cloud, and now all this means is that all the advantages of storing, processing, analyzing data in the cloud, all the wonderful, incredible things that Kenny has talked about, Daniel and Chris have talked about, Carto inherits all of those advantages without lifting a finger. Frankly, working in the cloud with other geospatial platforms is a little bit of a headache. It's not easy to maintain, but that's not so with Carto. With Carto and Google Cloud, it's seamless. And I can show you just how seamless it is. This video plays, what you're looking at here on the screen is me, just yesterday, connecting to a Google Cloud BigQuery project, one of the same ones that Kenny was just showing, connecting to that in 30 seconds from within the Carto platform. This particular example comes from the safety analytics project that we're currently working on with the Hawaii Department of Transportation. And just like that, I'm plugged into my data. I'm plugged into a scalable, enterprise-grade data warehouse in the cloud. If you don't have a data warehouse, it's no problem. Every instance of Carto comes with one included. And so what can you do with Carto and Google Cloud? Today, I'm going to give you just one taste, one little example. Our website, the documentation from Google, is filled with dozens of use cases and tutorials for other public sector applications as well. I know I was talking with some other folks earlier here today as well about some of their transitions from Esri products to Google Cloud and Carto. We've actually just released Workflows, which is our answer to Esri's Model Builder, if you're familiar with some of that vocabulary. But today, I'm just going to be showing you a little bit about the tip of one iceberg. And for that, I have another little video demo. What you're looking at on the screen right now is the dynamic and instantaneous recalculation of a climate vulnerability index. This comes from another project we've been working on with the DOT late last year. And so you can see, navigating to the index, you can see as it's scrolling, you can see all of the data sets going into the calculation of this index. We have sea level rise, storm surge, wildfire risk. All of these data sets we are combining together to come up with a single number that is representative of the climate vulnerability of infrastructure assets in an area. And we can modify how these data points are multiplied together and weighted against each other. That's what you see me doing as I'm moving the sliders back and forth there. You can notice how that causes changes in the map. And so what we're doing here is recalculating this vulnerability index on the fly based on our custom modifications. Now, some of the specifics here are not necessarily important. I mean, this could be any data, not just sea level rise data. And we don't have to just add them together. We can throw in any mathematical operation that you can think of in there. I know we have a lot of different entities and organizations represented here today, and so I want to take a quick ask in the audience. What data would you all like to see up here? Anyone can throw up a hand if you want. What data would you like to analyze in real time in the cloud? Yes. Crash data, that's a great one. Yeah, that's actually what we were connecting to in the early one. You might have seen that came from FARS. That's the Fatality Analysis Reporting System that's reported out by the federal government. That's a great one. We're doing that in safety analytics right now. I love that. Any other data sets, data sources that your group commonly works with? Raise your hand or call them out. Well, I know I saw a lot of different name tags out there. The Department of Health, I saw the City and County of Honolulu, I believe. You can imagine doing this, taking this approach for a lot of different things, whether it's COVID case counts. I saw the Board of Water Supply, pumping station levels, emergency services provision, and monitoring. The possibilities are really endless with this. And that's because what we're doing here is going beyond just simple visual inference. We're going to a real quantitative and data-driven methodology. And actually, you can see here, I'm going to go to a specific point in the video. You can see here I can display one of the data sets behind this index. In this instance, this is landslide susceptibility. If I wanted to display the other 10 data sets going into this index, there's no way I could do that on the same map. What I can do is capture everything, big data and small data, into a single meaningful measurement. That's what we're doing with this indexing here. And that helps us to overcome one of the big challenges with the data ecosystem, the data sphere, as Daniel coined it. That helps us overcome one of the big challenges with the data sphere today. And broadly, that challenge is synthesizing dozens, hundreds of different variables. This is much different from a century ago. I mean, this is much different from 20 years ago, right? Think of what you had to do to get census data in 1910 as opposed to 2020, or even 2000 as opposed to 2023. No matter what your application is, if it's safety, if it's climate resilience, if it's business development, if it's asset management, you need to bring together many variables to consider, to deliberate, and to make a decision, to arrive at a plan of action. That can be a challenge because that data is in a lot of different places. It's in a lot of different formats. It might come in a lot of different spatial resolutions. Chris earlier today and Kenny just now was explaining how you can bring all of that together in the cloud. With Carto's Spatial Data Catalog, you can start to browse some of those data sets in the cloud, select the data that you want, and bring that data into your analysis in under 30 seconds. Carto and Google Cloud bring it all together, make it easy to use, make it easy to work with, and perhaps most importantly, allow you to revise your analytical assumptions on the fly. And for that, I'd like to go back to the video again. What if I decide, or my department decides, or my committee decides, that we should weigh some variable higher for some reason that we agreed on? Well, previously, if you were working with a third party, if you hired someone to write a report and you want to go back and change something about that analysis, you have to go back to that third party. You have to go back and redo that analysis. You might have to reformulate that report in order to accommodate that change. But that's not so with this approach. Say new research shows that saltwater intrusion is more harmful than previously thought. I can go in and I can increase how that data set is weighted in the analysis. If one piece of information isn't a factor anymore, I can go in and I can decrease that, or I can remove it entirely. If I get new or updated data, and listen to this, if I get new or updated data, I can add that in real time, and I can act on it in real time. I don't need to wait 6 months, 9 months, 12 months to update my conclusions based on the latest data. And again, this is just one example that we've had the privilege to work on so far. This is climate resilience with the Hawaii Department of Transportation. But this is broadly applicable to any situation in which you have a lot of data, where you have to look at many different variables in order to arrive at a plan of action, in order to make recommendations, in order to act on decisions. There are other indices and index approaches out there. The federal government puts out more than a few. Think of things like FEMA's Hazard Index, the EPA's Equity Index. But these have some drawbacks. These are benchmarked nationally. They might not be suitable for all locales or jurisdictions because they're not locally nuanced. Especially here in Hawaii, I'm sure you all can think of a handful of examples where an assumption that might be reasonable in the continental United States doesn't fit quite well with the reality on the ground here. As a case in point, thinking about the EPA's Equity Index, that doesn't include anything specific about Native Hawaiians. In the climate example I was showing earlier, another one of the indices that we actually went in and created was a locally nuanced equity index that took into account Native Hawaiian population, the presence of Hawaiian homeland parcels, and the number and location of housing units, for example. What this lets you arrive at is a single number or a small set of indicators tailored to you, that's relevant to you, that's relevant to your jurisdiction, that's relevant to your objectives. And with this approach, we can incorporate local knowledge, like in the equity example I was talking about. We can enable the easy revision of assumptions and data sources. We can overcome the constraints of visual inference so that we can be leveraging the whole data ecosystem and doing so in real time. And we can set it up for self-service. We can set you up with a Carto account where you're logging in and you're modifying those sliders yourself. All that so that we can put the power of the cloud and geospatial cloud analytics in the hands of the public sector. Thank you, everyone, for a little bit of your time. I don't know if we have time for one or two burning questions. Otherwise, all right, we have time for one or two burning questions, if anybody wants to throw up a hand. Otherwise, I'll just let the video play in the background again. And if there's no questions, I'll turn it back over to you, Kenny. Again, thank you, everyone.
Thanks, Toby. Thank you. And last slide, I want to, before you leave, I want you to remember, of course, you're going to have a stay for happy hours, right? Remember, we talk about application development, Carto, we talk about Looker, build your applications using the data, and we talk about BigQuery as engine. We talk about Analytics Hub. We talk about data ingestion with Cloud Data Fusion. Those is the one tools we have. We have some other tools. Of course, we're also working very well with the third-party applications. So when you walk out today, I want you to remember, we are a whole platform. We taking care of your data. We help you analyze your data, and we help you start with your data and do the AI or machine learnings. And please, and if you have more questions or any project on your minds, and you know who to reach out, right? Then Daniel, he knows probably many of you. And from Daniel, you can reach both Toby and me and the other folks we have here. Thank you for your time. And I'll pass back to Daniel. He probably give some.
Well, thanks everyone. Let's give a round of applause to our speaker here. Yeah. So our last session is the most important session is the happy hour. So we'll have just in a couple of minutes, let's just hang around this area and have a great conversation. We have a lot of what we call Googlers and our partners here. They help us to deliver all those solutions here. So if you have any questions, please just find one of us and ask those questions here. Thanks for attending.